Hello and welcome to Nature Days Outdoor Learning Resources, sponsored by the Gower Society. And you might notice that we are not in my garden. We're here on location, we're on the beach. But it doesn't matter if you're not close to a beach, you don't need to be on a beach to undertake this challenge. Because my challenge today is all about estimating. And we're going to use sampling to work out ways of estimating the number in a population. And we're going to use the example on the beach to help you to use the tools of estimating to work out the population in your garden of one of the species that hopefully you'll find in your lawn. Okay, so what we're going to do today is we're going to estimate how many barnacles there are living on the rocky shore here. Now, I do not want to spend all day counting every individual barnacle. That's going to take an awful long time, and the tide's going to come in and it's going to be very boring. So I'm going to use my skills of estimating and sampling to estimate how many there are on the beach here. And we're going to use what's called a sample. Now, a sample is just a representative area of our location that we can use to estimate a larger area to look at how many there probably are in the whole population in our location. Now, the sample size that I'm going to be using is a square, but it could be any shape at all. It's just a set size that you're going to use to do your estimating inside of. So I've got a sample size down here, and this is called a quadrat just because it's a square shaped. And this size here, if you look down, this is a 1/2 metre by a 1/2 metre, so we've got a 1/4 metre squared. Now, first of all, I just want you to have a look inside and see if you can estimate how much there is covered up by our barnacles. So these are barnacles here, these little white things here, these little animals, they're stuck to the rock. I'll tell you more about their life cycle in another film. And these are covering a percentage of our sample size. So you can either do it in a fraction, you can say it's half covered, or a quarter, or you could say it as a percentage. So I'm just going to leave you with a picture of this quadrat, see if you can estimate the percentage of this square that is covered in our barnacles. Now, it's quite tricky to estimate the proportion of our quadrat which is covered in barnacles because they're not all in one area. So if we wanted to colour in, say, a half of this quadrat, we'd colour in 1/2 like this. But our barnacles are all over the place. So there's a small group over here, another group there, there's not many here, and then this bit is full of them, this bit full, and this bit. So all those bits together, we need to add together to get our proportion of our square. And that's tricky when we've just got one open area. So what we can do is we can divide our square into sections, and that will help. So I've got another quadrat here, same size, and if I put that over the top, that's divided it into 1, 2, 3, 4, 5 squares by 5 squares. So we've got 25 squares now, and we can then count if there's a full square full of our barnacles, and then we can say each of our squares is a proportion of the whole. So if we've got 25 squares here, each square is how much of a percentage of the whole? Each square is going to be 4%. So if we've got one there which is full, that gives us 4%. If that one's full, that's another 4, that's 8%. And we can keep going along and see how much of a percentage is covered by our barnacles. But we've got a bit of a problem. There's one here which has got 2 barnacles inside it, and it wouldn't be fair to say that was full of barnacles. So that's not 4%. So we can make this more specific and much more accurate and precise by dividing it even greater. And this one has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So this is 10 by 10 squares. So we've got 100. So every single square is just 1%. And then we can see if that square's full, that's 1%. And we can count how many squares are full of barnacles, and that number will give us a percentage. And each way we're being much more precise than if we just estimated from our open space. But this is just one location. So if I said this was 50% covered in barnacles, could I really say that the whole beach was 50% covered in barnacles? It's a bit of an estimation, but it's not very fair because we've only done one small area. So when you're doing sampling, you need to do a number of these so that you make sure that your data is actually reliable. If you do one, you might just find a spot which has got more than you expect. You find a spot that's got lots of barnacles, or you could be in a spot that's got hardly any, and that's not fair. So we need to do a representative sample, which means more than one. So I'm going to repeat this in 10 different locations all around my area here. And in each one I do the same system and I work out the proportion of the square which is covered in barnacles. Now from that I can calculate my mean average, and that will tell me the average proportion of barnacles in one of these quarter-metre squares. Then I can either measure the area of the whole rocky shore, or I can use a map, and then I can say, right, well, if the whole rocky shore is this metres squared, and each of my quarter-metre squares was half, then I can actually calculate how much of the area is covered in barnacles. So that's me finished showing you how to do it on the beach. Now we're going to go back to the garden so that you can have a go in your lawn. So here we are back in the garden, and my challenge for you is to estimate how many plants there are in your lawn. Now, I'm not looking at how many blades of grass and even how many different plants there are, although we can do that. I want you to pick just one flower, something really obvious that there's quite a lot of in your lawn. Not too many, but also too many that you really want to go around and count them. Then you need to find your sample size. Now remember, it doesn't matter what size it is as long as you keep the same size and it's smaller than your lawn. So you could use 4 sticks to make a square, or 4 rulers. You can even use your foot. And if you put your foot on a piece of paper and cut out the size of your foot, you can make a footprint. Now this is your sample size. So look inside your sample size, and then you can either measure the proportion of that area which is full of your chosen plant, or you could count how many individuals there were. So I'm going to do daisies, and I could count what proportion of my square here was full of daisies. So I say probably about a quarter of that square is full of daisies. Or I could do it with my footprint, and I could see that I've got 2 daisies inside my footprint. Now you need to estimate how big your lawn is. You could measure it and work out how many of your sample size squares would fit inside your lawn, or you could just estimate by looking at the size of your sample size, looking at the size of your lawn, and estimating how many of those would fit inside your lawn. Now remember, I said if you just did it once it wasn't very fair, so you need to repeat it. So take your sample size, your square or your footprint, around your garden and take at least 10 samples. So do it 10 times. Then you need to calculate your mean average. And to do that, you total up the number of individual plants from all of your 10 sample sizes and then divide it by the number of sample sizes you took, which is 10. And then you should have a mean average. Then you can estimate out of your whole lawn what the mean average for the whole lawn was. So after I'd done my 10 samples and I managed to find a mean average and they all made a quarter of my sample size, and I measured the size of my lawn and it came up as 10 square metres, then I can say that a quarter of that is probably covered in daisies. So how much is that? A quarter of 10 square metres. Okay, so that's how you calculate it. Now, if you would like to do the maths, I'm going to put a blog up to explain it. But we could have a look and just see if proportions are the easiest way to explain it. Because when you're doing data collecting like this, there's so many ways of actually measuring. Because usually you don't want to count everything, so you work out an average or a median or a mode. And these are all statistics. Now, maths is great to do outside, and I really hope you do enjoy doing a bit of maths this morning in your garden. Good luck and have fun.